Hi, my name is Arbery Smith and this is
Colleen Bigler.
and today we are here to teach you guys about inequalities.
A relation that holds between two expressions when they are not equal, employing a sign such as not equal to or greater than or less than.
Okay, so I know that sounded really complicated, but it's really simple. Let me give you guys an example. Step 1, set the equations apart.
Step 2, make both equations equal to 0.
Step 3, solve them and see if they are true. So I'm going to take this part of the equation and Colleen is going to take this part, and we're both going to set them equal to 0. So after you set the equations equal to 0, you're going to add or subtract the number next to the variable to 0. So in my equation, I had 2x plus 8 equals 0. So I subtracted 8 from both sides so that it canceled out, and 2x was by itself. 2x is equal to negative 8, and you divide them by 2 so that x is by itself. My answer was negative 4.
And for mine, you minus 12 from the side and put it on underneath the 0. And once you do that, then you put 4x equals negative 12 and divide 4 and put it underneath, and you get x equals negative 3.
Now our question was it true or false? 2x plus 8 is greater than or equal to 4x plus 12. And our answer is because negative 4 is less than negative 3. So the answer to our question would be false.
This is another example of inequalities.
So my half of the problem is 12x plus 48.
And minus 30x minus 40. And we're going to solve these equations.
Okay, so first thing we're going to do again is we're going to split them apart. So my half is 12x plus 48 is equal to 0.
And mine is 30x minus 40 equals 0.
So the first thing I'm going to do is subtract 48 from the 0 and from itself. So minus 48 minus 48. Now that leaves me with 12x is equal to negative 48. So what I'm trying to do is get x by itself. So I'm going to divide both of these by 12. X is equal to 4.
And for mine, I'm going to add 40. And that gives me 30x equals 40. After that, I will divide 30. And that gives me x equals 4/3.
So, as you see, solving inequalities isn't that hard. I mean, I know it sounds very hard and it looks very difficult, but it's really not that hard. Hi guys, we're back again talking about inequalities. Earlier we taught you guys about inequalities themselves, but we're going to add the second part, rational inequalities. But before we get started, my name is Arbery.
My name is Esteban.
My name's Colleen.
Okay, so basically the definition of rational inequalities is a rational expression changes its sign only at zeros and its undefined value. So here we have an example, x minus 1 over x plus 3 is greater than 0. And basically you can see it as a separate problem. So x minus 1 equals 0, and you just solve it and you get 1. And then x plus 3 equals 0, and it equals negative 3.
Then you try to find a solution for the problem, which when you plug in negative 3 on for x, you get negative 4 over 0, which that doesn't work. And so that's why you have to put a clear 0, well, O over it. And then you plug in 1, and that makes that 0 over 3. That doesn't work because 0 is not greater than 0. They're pretty much the same. So you can put any number that's behind these two numbers to fit that are intervals to see if it fits in. So I put negative 5 and plugged it in. So negative 5 minus 1 is negative 6, and then over that is negative 5 plus 3, which is negative 2. And that makes it 6. Well, no, it makes it 3. So after that, that works, and so you would shade it in right here because it tells that that's true. Then you plug in x equals 3. So you put 3 in here minus 1, and that gives you 2. 3 plus 3 is 6, so that's 1 over 3. And that's 1 over 3 is greater than 0, so you would shade in that part. And so x equals 0. You plug that in, you're pretty much eliminating the x, and that's negative 1 over 3, and that's not greater than 0, so that's not true. So that's why we didn't shade this part. And when you write it down, it would be negative infinity because of this being shaded, that's negative infinity, and then put negative 3 in for it. After that, or you would put 1 infinity as the next one for it. And to check the work is right there.
Oh, she pretty much did it already.
And thank you for watching. That is Rational Equalities with Arbery.
Esteban.
And Colleen.